the next test is the independent samples t-test. And to do an independent samples t-test, I will start by loading some data. So we're going to open the welcome dialog and find the sample file that has the credit promo dataset, which is the sample that talks about two samples. So there's one treatment where people get either a standard or a new promotion advertisement, and then it keeps track of the money they spent. So we'll just change that to dollars. And now we will go to our test. So we do analyze, compare means, independent samples t-test. So the grouping variable is the type of mail insert received. And our two groups are 1, they got a new kind, or 0, they got the old kind. And by putting it in this order, we'll subtract, it'll be the money spent by the new kind minus the money spent by the old kind, and that will give us a positive difference if the new kind was beneficial. So that's what we do it that way. Put that in test variables and hit OK. So here are our results. Now in a single sample t-test, an independent samples t-test, they give the group statistics and then you get the t-table. So the group statistics show us the means and the standard errors. So you could actually compute a t-score right here by subtracting these two and using those. But so we say these two do have a different mean. The new promotion's a little higher, so it might be significant. And now we have two lines for t-tests. So we've got confidence intervals, standard errors, mean differences. Those are going to be the same. What will be different are the degrees of freedom, and therefore the significance. And these two rows are computed in different ways based on how similar the variances are within our two samples. So the old-fashioned way is to make the math simpler and assume that both variances are the same. And then the more complicated way, which is hard to do if you have pen and paper and easy to do if you have a computer, is to compute two different variances, one for each sample. And so that's what we should always use. So basically you should ignore this top row and only pay attention to this bottom row. These 4 cells here are a significance test to see if you should switch. But in practice, since this is already computed anyway, it's all you should use. So how will we report this? So we have a significant result, right? This sig is what SPSS calls a p-value. So we will do a graph. We'll do a bar plot. So we do a bar plot with the type of mail insert here and the money spent here. We want the mean. We want error bars. We want those error bars to show standard errors. I like standard errors more than confidence intervals because confidence intervals also require this sort of estimation of the percentage. And that's an extra thing for people to wrap their brains around, where you just say one standard error up and down, and then they can compute confidence intervals from those themselves. And standard deviation is not as good as standard error because it doesn't take sample size into account. And once again, we'll take the liberty of deleting the title at this stage. Now hit OK. So there's our graph. So again, copy this into Word, paste it here, and then our results are there was a significant, so let's see, people that received the new promotion spent a significantly more with their credit cards than people did with the old promotion. Mean difference plus standard error equals, so go down to our mean difference is $71.11. So 71 Standard error is 31.46. T. See, our T value is 4 degrees of freedom are 498. Round those up. 498 equals 2.26. P equals 0.024. And that is our... Oh, that's from our previous one. I didn't copy. Silly me. Let's go back. Copy. Paste. There, that's better. The actual results from our actual study this time. So there you go. Small but noticeable difference.